Okay, let's draw some squares. I've got a brand new sketch here, called it Overlap Demo Live. And I'm going to go ahead and add the setup and size and the draw functions. You're going to see me copy and paste quite a bit because A, you don't want to have to watch me type everything, and B, my wrists are getting kind of tired. So we're going to start with drawing a square by hand here, which is pretty easy. We're just going to use the built-in function called rect for a rectangle. It takes an X and a Y for the upper left-hand corner, which I'm putting at 50-50, and it takes a width and a height, which in this case it's a square, so they're both going to be 25. And when we run it, we get a square. Pretty cool. Okay. So now let's make some more squares. Well, here is a very simple way to make more squares. You can just copy this and paste it. And then since these are all in the same coordinates here, we want to move it a bit. So let's just call it, I don't know, let's add 75. 1, 25, and then another 75 would be 200. Oops, 2000. And we'll say save it and run it. And there we go, we have 3 squares. So that can get tedious pretty quick. And luckily, the computer can do all this for us. We can tell it how to generate this sequence of 3 squares by using what's called a for loop. And it looks like this. Actually, I'll just paste it. I'll copy and paste here from my example, or from the completed version of this file. Oops, that didn't work. Okay, so formatting issues. For loop looks like this. You have the word for, and then you have, in parentheses, you have 3 little expressions separated by semicolons here. So the first one says int I equals 0, which we know from last time just declares a new integer named I and sets it to 0. Then we have a block that says, it's a condition that says I is less than 3, which is obviously true when at the very beginning because we set I equals to 0. And then we have an expression or a statement that says plus plus I, which just means add 1 to I. It's almost the same as I plus plus. There's minor differences, but for the sake of argument, this is the same. It just adds 1 to I. And then it has a block. And the way this is going to work is it's going to do this at the very start. It's always going to run this one. And then it's going to check this. And if this evaluates to true, it's going to do this, or it's going to do the block, and then it's going to do this. And then after it does this, it's going to come back here, and it's going to evaluate this. And if this is true, then it's going to do the block, and then it's going to do this. And it just goes around in a loop until it gets to this again, and it is false. So basically, you have I equals 0. It's going to do the loop, add 1. I equals 1. It's to less than 3. Do the loop, add 1. It's going to be 2. Add 1, and then it's going to be 3. And so it's going to happen 3 times. And the values will be 0, 1, and 2. Because it never will get to 3 because it has to be less than 3. So when we do this, I did the same math. I took the I, which is this right here, the counter here, and I multiplied it by 75. So the first time is 0, so it's just 50, which is what we had before. And then we're going to add, we're going to add 75 times 1, and then we're going to add 75 times 2. So it's going to do the exact same thing. And there we go, same thing. And that's what a for loop is. Okay, let's see what's next. Oh, and also the name of, I called it I here, but it could be anything. The I is just kind of traditional when you have a counter, and you don't really care what it is. So that's that. Let's see. Loops can be nested. So let's put another copy in here that is. Actually, I'm going to line up the source when I copy it. Copy, and I'm going to replace this with a new version that is the same, except now it's got another loop around it. So this is what when I say they can be nested, I just mean that you can stick one inside the other. And again, when you do that, J is kind of the traditional next letter to use. But you can also use X and Y, and sometimes if there's some like specific meaning to the names, then you can use better names. But so we've done this. So I've added another loop that's also 0 to 3, or 0 to less than 3. So, and then I've changed the y coordinate here. So we're actually going to get 3 loops here, and then we're going to do 3 loops in the middle. So it's actually going to have 9 rectangles, or 9 squares, which is this, which is kind of what we're shooting for in this system. So the goal here is actually to move these around with the mouse. So that's kind of too big of a step to take on just yet. So for the time being, I'm going to go back to just having one square, and we're going to see if we can get the mouse to interact with that one square. So let's see. I guess I didn't paste that one, so I guess I'll just go back to this and just get rid of these. Delete it. Delete it. Indent that a bit. Something's wrong with my formatting here, but and we'll get rid of all the stuff about 75 and all this stuff about 75, and just go back to having a box. Okay, and so now we're gonna just interact with this one box, and I'm gonna have it change colors when we click on it. So we can start by just having it change colors when we click anywhere. That's pretty easy. So first, we're going to have to actually, if we're going to change the color, we have to keep track of what the color is. So we're going to create a variable out here, and we're going to call it mColor, following my naming conventions. Color, mColor, and we're going to have it default to white. And then in here, we're going to say fill, mColor. And there you go. That should do the exact same thing we had. I'll make this blue or something. So blue would be no red, no green, all blue. There we go. So it's doing it. And I'm going to make it white again. Okay, success. Okay, so we've got a draw, we've got a fill, and we've got our rectangle still. So let's change the color. So to change the color on the mouse click, we have to detect the mouse click. So that is void mouse pressed. There we go, easy stuff. And we'll just say mColor equals random. Equals color, and then we have to pass in random integers for the red, which is 255. FF is just 255. 255. So it's 00 through FF in hexadecimal, or 0 through 255 in decimal. And when we do this, we click anywhere now, and our square changes color. But that's not exactly what we want. We want to kind of limit it so that it only changes color when we click inside the square. So, how do we do that? Well, in processing, we have 2 variables that are called mouse mouse X and mouse Y. They're kind of like the key and key code for the keyboard that we saw last week, except they track the X and Y coordinates of the mouse. And you can read them inside a mouse pressed event or any of the mouse events. Excuse me. So, basically, in order to make sure, comment that out real quick and run it. In order to make sure that we're clicking in here, all we have to test for is that the mouse X is in between these two lines. Well, we know that's 50. The left is 50 because we set the rectangle to 50/50, so that's an X of 50 and a Y of 50. And this has got to be 75/75 down here because we know it's 25 across and 25 down. So all we have to do is check to see whether the mouse X is in between 50 and 75, and then whether the mouse Y is in between 50 and 75 going this way. And if it is, then we know we're in the right place. So that would look like this. And I'm going to copy and paste this one because it's lots of little weird characters to type in. Yeah, it's easy stuff, but probably get it wrong if I just typed it. Weird keyboard too. Okay, it looks like this. So certainly didn't paste very nicely, but it looks like this. And we want this to be on the outside of the loop. As I said, remember I said last time, you always want to have these line up either with the keyword or with the other brace, depending on your particular style, but definitely want them to line up to show you the structure. So here we have an if statement inside the mouse pressed function, and actually you notice that processing will highlight the other. If you click on one or whatever, it'll put the cursor over one, it'll highlight the other, which is kind of handy. A lot of nice editors do that. So this is all one Boolean expression, Boolean meaning true or false. And it is exactly what we just said. We said the mouse X is greater than or equal to X, or actually X is less than or equal to mouse X, and mouse X is also less than or equal to the X plus the width. Now I used letters here, so we're going to have to actually introduce these letters, otherwise, I mean, it would be just ridiculous to fill in the numbers every time. Especially if we want to change the location of the square. So we're going to go ahead and create these variables here. So we're saying int x equals 50, int y equals 50, int width, or w, equals 25, and int h equals 25. And then in here we're going to say x, y, width, and height. And so that's what this does. This will now make our equation work, and this is just and. One of them is the bitwise and, but two of them together does a Boolean and. It does the true and false values. So all of those ands together are just like plus signs except for true. So we're saying they're all true. So all of these things have to be true, and if so, then it'll click. So hopefully when we do this now, we'll only get the changing color when we click inside the square. And I'm clicking all over and nothing's happening, and I click in the square and it changes color. This is exactly what we wanted to do. And then the next step, we're going to go in and go back and add the other 8 squares.